Hello dear students, today we'll be continuing with the aromatic compounds and in particular aromatic hydrocarbons. So aromatic hydrocarbons are those compounds. These are two hydrocarbons. That means they are also made up of hydrogen and carbon. But here this aromatic means they have some peculiar aroma, means they have particular smell, and because of which we can identify them from other compounds. So aromatic compounds, whenever we speak about aromatic compounds, you have to know one more thing, that in aromatic compounds resonance takes place. So resonance means, see here you have a benzene ring, and benzene is an example of aromatic compound and it's very common. So benzene contains a ring in which we have 6 carbons and 6 hydrogen, so it can also be written as C6H6. So its structure is in ring form, where we have alternate single and double bond. There are 3 double bonds and 3 single bonds. Now this benzene, the double bonds in benzene are not fixed at its only one place, but it keeps on resonating, means it keeps on resonating, changing its position within the ring. Now as a result of that, we can have another structure where benzene has this double bonds. It has changed its position of double bond. Now these two are the canonical structures of benzene, and benzene can also be written as 6-membered ring with a circle in center. Now this circle in center means the single bond and double bond, they are not fixed, but the double bond, they keep on resonating within the ring, because of which benzene is very stable. So another example of aromatic compound is naphthalene. This is the example of 2 benzene rings fused together, and here the name of this compound is naphthalene. This is also aromatic. So now let's discuss about benzene in more detail. Benzene can be prepared from sodium benzoate. So this is the formula for sodium benzoate. Benzoic acid. Benzoic acid is benzene ring along with COOH. Now when H of COOH group is replaced with sodium, then we get sodium benzoate. Now sodium benzoate, whenever it's treated with soda, lime and heated, then what will happen? We get benzene. This is the benzene, and the byproduct is sodium carbonate. So how the reaction takes place? This sodium carbonate will be eliminated, and this hydrogen here will be going and taking this position. This bond will clip. Now this carbon bond will be clipped, and in its place this hydrogen is coming and replacing this COON. So this is the one of the method for the preparation of benzene, and this is from sodium benzoate. The next method for the preparation of benzene is from phenol. So phenol is benzene ring along with OH. Now OH, whenever it is present in benzene ring, then its name is phenol. So phenol, when treated with zinc and heated, what will happen? We get benzene. So these two reactions we have to learn properly. These are the 2 ways in which we prepare benzene. Now the most important part of aromatic hydrocarbons is here. This is electrophilic substitution reaction. So please listen carefully. What is electrophilic substitution reaction? So you know what is electrophile? Electrophiles are electron loving. They are what? They are electron loving groups. Electrophiles are electron loving groups, and they usually have a positive charge over them, or they are deficient in electron. So here E plus means it's an electrophile. Okay, so whenever benzene ring is treated with electrophile, then substitution reaction takes place, means this hydrogen of benzene, the hydrogen present in benzene will be substituted with electrophile. Now this electrophile will come over here and this hydrogen will leave this molecule, and because of this, this is also known as what? Substitution reaction, because hydrogen is being substituted with electrophile. And why electrophilic? Because electrophile is substituting this hydrogen. The mechanism of electrophilic substitution reaction is also there in your syllabus, so please look at it carefully. Mechanism. So we have benzene ring, you know, in benzene we have alternate single bond and double bond. Now these pi electrons of the double bond, now they are what? They are electrons, because of which now these negative electrons are what? They are negatively charged, so they will be attracting the electrophile. Electrophile is having positive charge, so you know there is always attraction between negative charge and positive charge. As a result of this, now this electrophile will form a bond with this carbon over here. This double bond is involved in bond formation, yes or no, with the electrophile. Now this double bond is used in the formation of bond with electrophile, and the electrophile is bonded to this carbon. Now the valency of this carbon is unsatisfied, because of which it has now positive charge. Okay, the double bond is not present here, because of which it has a deficient. This carbon is now deficient in electron, and its valence is not fulfilled, because of which it has positive charge. Now this positive charge now can be neutralized with the pi electrons present within the benzene ring, and here the shifting of pi bond will take place. This shifting of pi bond within the molecule is known as what? Resonance. So this bond now will be shifting here, as a result of which now here we will be having double bond, and again here the positive charge will be shifted here. Okay, the positive charge is shifted here. Why? Because again now this carbon's valency is not fulfilled, it's unsatisfied. Likewise, again this double bond which is present over here now will be shifted between this carbon and this carbon to satisfy the valency of this carbon, the positive charge. Now when this is shifted here, then again the positive charge is generated here. Now at last what will happen is, in the reagent if you have some negative charge, negative substrate, now that will abstract proton from which carbon? You have to remember this point is very important. It will abstract the proton from that carbon to which this electrophile is attached. Can you see this? Here electrophile is attached. Now this negative substrate is abstracting this proton. Proton means hydrogen bonded to the carbon to which electrophile is attached. Now once it abstracts this hydrogen here, then the bond between carbon and hydrogen, now it breaks, and it breaks this bond here means what? 2 electrons. Now these 2 electrons will be shifted between this carbon and this carbon over here, and as a result we get a double bond here. Now you can see, now again the aromaticity, that means the benzene ring is regenerated. Benzene ring with alternate double bond and single bond. So this is the mechanism how this electrophilic substitution reaction takes place. The same mechanism will be followed for all kinds of electrophilic substitution reactions in case of benzene ring. Please, this mechanism is there in your syllabus, you have to practice them properly. Now let's discuss about different types of electrophilic substitution reaction. The first one is halogenation. Okay, the first one is halogenation. So halogenation means addition of halogen to the benzene ring, and this is one of the type of electrophilic substitution reaction. Here the same mechanism that we discussed just now, we discussed electrophilic substitution reaction, the same mechanism will be followed. Okay, so here we can see halogenation. We have a benzene ring, and hydrogen is attached. Now whenever this benzene ring reacts with halogen, now in here in particular we have taken bromine, Br2, and in presence of a Lewis acid, okay, FeBr3. So in presence of Lewis acid, what will happen? There is substitution of this hydrogen with bromine. So you can write this bromine as Br and Br, okay. So this HBr will come out as HBr molecule, and this Br will be attached to this carbon, as a result of which we get bromobenzene. The name of this compound is bromobenzene, okay. Similarly, if you have chlorine over here, then you have to take FeCl3. Now again the reaction would be same. Instead of Br, you would be getting Cl, and here it would be HCl. Now let's discuss about nitration. What is nitration? Whenever we treat benzene with concentrated nitric acid as well as concentrated sulfuric acid, then whenever these two reacts, okay, concentrated nitric acid and concentrated sulfuric acid, you get other product, but the main product of our concern is NO2 plus. Now this is the electrophile that is generated. Please remember, whenever in case of nitration, concentrated HNO3 and concentrated sulfuric acid, they react together to give NO2 plus as electrophile. Now this electrophile will be substituting one of the hydrogen of benzene ring, okay, as we have discussed, and we would be getting the substitution product, and the substitution product here is what? Nitrobenzene. Whenever nitrogen is in NO2 group is present in benzene ring, then that is known as what? Nitrobenzene. So these are very simple reactions, but you have to remember the reagents used and the electrophile that is generated, okay. In case of sulfonation, benzene ring, the benzene is treated with concentrated sulfuric acid, and after the reaction, again here the substitution of one of the hydrogen of benzene ring takes place with SO3H group, and we obtain the substituted product, okay. The next example of electrophilic substitution reaction is Friedel-Crafts alkylation. So alkylation means we are going to add alkyl group. Now alkyl group will be substituting the hydrogen of the benzene. So you can see in this reaction we have benzene ring reacting with RX. RX is what? Alkyl halide. This is alkyl halide. In presence of anhydrous aluminum trichloride, we obtain the alkylated product. See, HX will be eliminated, and now this R will substitute this H. So in place of H, what has come? R has come. So this is known as what? Alkylation. And since it is given by Friedel and Crafts, therefore it's known as what? Friedel-Crafts alkylation. Alkylation means addition of alkyl group. So alkyl group is present now after the reaction in the benzene ring. So in particular, if we have to take any particular example, then you can see CS3Br, we have taken CS3 in place of R, we have taken CS3 alkyl group, that is here it's methyl. So this HBr will be eliminated as SBr, and now this CS3 group will substitute this hydrogen's place, okay. Therefore it's known as what? Substitution reaction. The next we have is Friedel-Crafts acylation. So please don't be confused. Alkylation means alkyl group will be present after the reaction. Acylation means you will be having some acyl group present in the benzene ring after the reaction. So this is benzene ring whenever reacting with some acyl chloride. Here it is acetyl chloride. So acetyl chloride, okay. So whenever benzene reacts with acetyl chloride in presence of anhydrous aluminum trichloride, then you can see this HCl has come out as HCl and this C double bond O CS3 is bonded to the benzene ring. Here you can see it, C double bond O CS3 is bonded to the benzene ring. And please, you have to remember it's this carbon, this carbon of acetyl group which will be bonded to the benzene ring, okay. Please don't make mistake here. I have seen many students making mistake here. So it is C double bond O this carbon being bonded to the benzene ring. So these were the substitution reactions, electrophilic substitution reaction of benzene ring. Now another important part that we are going to discuss is directive influence of substituents. Okay, directive influence of substituents in electrophilic substitution reaction. So this is very simple if you understand it, and this is very important as well. So benzene, we have discussed about benzene ring. Now if in benzene ring some electron donating groups are present, electron donating groups like I have given over here, OH, OR, X, NH2 or NHR, etc. If these groups are present over here which is attached with benzene ring, then these are what? These are electron donating groups. So electron donating groups, as the name itself suggests, they will donate the electron towards the benzene ring. Okay, once they donate the electron towards the benzene ring, resonance takes place now. So the negative charge is now delocalized all over the benzene ring, and our main concern over here is this one. See, you can see during the resonance and in resonating structure, we can see here this negative charge is present at which position? At ortho position, at para position, and also at ortho position. So negative charge has come over ortho position, para position, and again at ortho position, but it never came at what? Meta position. It never came at what? Meta position. It did not come at meta position. So from this we can say that whenever electron donating groups are present, then it will enrich which positions? It will enrich ortho position and para position with more negative charge. Okay, please remember this part is very important. And in case of electrophilic substitution reaction means what? Electrophiles are electron loving. Now this electrophile, okay, if it is now reacted with benzene with electron donating group, then we saw that it has the negative charge. It comes at ortho position and para position. Now this positive charge will be forced to go to either ortho position or at para position. Why? Because it is positively charged, and negative charge is readily available at which positions? At ortho position and para position, because of which the incoming electrophile will be directed either to ortho position or to para position. So you can see after the reaction this electrophile is bonded at ortho position or at para position. So this is the directive influence of substituents. Okay, now because of the presence of this NH2 group, now NH2 group is what? Electron donating group. Because of the presence of NH2 group, the electrophile is bound to come at ortho position or at para position, and the products obtained are ortho directed product and para directed product. Means whenever we have electron donating group in benzene ring, then it acts as ortho and para directing groups. In which case? In case of electrophilic substitution reaction. So please remember, in case of electrophilic substitution reaction, if electron donating groups are present in the benzene ring, then they are what? They are ortho and para directing group. Hope this is clear. Now if you have electron withdrawing group, now electron withdrawing group, now this is EWZ, electron withdrawing group. Electron withdrawing groups like C double bond O or C double bond O OH or nitro group or cyanide group, etc. If these groups are present, then they withdraw the electron from the benzene ring. Okay, they withdraw the electron from the benzene ring, and if electron withdrawing groups are present, then the incoming electrophile will be now directed at meta position. See, you can see this electrophile is bonded to the meta position. This position is known as meta position. You have to remember this is very important. If electron withdrawing groups are present, then in case of electrophilic substitution reaction, the incoming electrophile will be directed at meta position. Okay, now directive influence of substituent in case of nucleophilic substitution reaction. This was electrophilic substitution reaction. Electrophile, E plus was substituting. What does then nucleophile mean? Nucleophile means they are nucleus loving. Nucleus loving means they will be having either negative charge or they will be having excess electron. Okay, so if electron donating groups are present, in case of which case? In nucleophilic. Now please don't get confused between electrophilic and nucleophilic. Electrophilic means electron loving groups. Now nucleophilic means nucleophile. That means they will be having negative charge. Okay, now this negative charge now will be directed to come at which position? At meta position. So you can see that in case of nucleophilic substitution reaction, if electron donating groups are present if electron donating group is present in the benzene ring, then what will happen? This negative charge will be, this negatively charged nucleophile will be bound to come at what? Which position? Meta position. So can you tell me why? Because electron donating group will enrich which positions? Ortho position and para position with what? Negative charge. Now this being negatively charged, this nucleophile, it cannot come to ortho position or at para position because like charges they repel, you know that. So it is now bound to come at which position? At meta position, because it doesn't have any negative charge. So this part is very important, and the same thing, the same concept will be carried out. You will be learning and you will be applying it in class 12 as well. So please learn them properly. What is electron donating group, what is electron withdrawing group, and what is electrophilic substitution reaction, how this electron donating group and electron withdrawing group, they are going to affect the product that we obtain, whether they are ortho para directing group or they are meta directing group.